Alrighty, welcome back everybody to the 15th week of our algorithm programming course at Tech Bytes program, where every single Monday we're tackling a new problem. And now for the past couple of weeks, for those of us who are coming back every single week, we've been talking about a topic. And this week we're going to keep on talking about that specific topic, seeing where and how the other things which we can do with it. As always, guys, thank you so much for coming out here today. It's the 15th week and we got much more ground to cover. Without any further ado, we got to get started off with the usual Quote Wars. You guys know who I am, guys. Ray, I'm Sneaky, a senior at Cohen High School, and my meme for the day is when you find that missing semicolon in your code, your mouth drops. Literally, it drops. So this is something more specific. If you ever work with the programming language of JavaScript, in Python, we're lucky. We don't have to worry about semicolons, but in JavaScript, if you forget a semicolon anywhere.
Java, I think.
Oh, with Java, yeah, with Java, sorry.
Yeah.
With Java, you'll have to go back and look through your whole program, and it's a nightmare. And once you realize that you made such a small mistake, you're like, how could I have been that what was I thinking at the moment when I made that mistake? So it's a jaw-dropping moment, but hopefully one which we won't have to make.
So before I say mine, no, okay, fine, I'll say mine. Okay. Chase sent his. Here's mine. If you can't win the Quote Wars, Rayan or love you.
I like it, Chase. I like it.
Very nice. Okay. So my quote or meme for today is: there are two states of every programmer. First is I am a god. Like you believe in yourself so much and you're so proud of yourself. But there's that other stage where you have no idea what you're doing, and that is absolutely like that is way more common, I guess, especially for me. But yeah, those are the two stages of basically every programmer.
Super true. Super semicolon not big of a deal when Avanish, when you're programming in Java, it'll be a huge deal, but
Yeah.
Alrighty. Well, looks like, yeah, a lot of you like it. You're either on a roll,
Let's go.
either on a roll, or you either have no idea. That's pretty true. So I like it too. That's good. Alrighty. Well, let's move on to a quick recap of what we're going to be doing for the upcoming month of not only finishing out April, but also May starting up in a couple days. So we're going to keep on our old programs going with algorithmic programming, product development, and video gaming hour, guys, finishing those out. And these will be going on till the end of May. And then starting out in June, we'll be starting up some new programs. It'll have been 5 months about when May ends up with all these programs. So we'll have done a lot of work in Python. So until then, this Wednesday, we got product development. If you guys have any ideas for projects, stuff like that, feel free to drop them in the Google Classroom. But other than that, we'll be starting something new this Wednesday. So stay tuned for that. But now, let's get to today.
All right. So today we are going to review recursion one more time. Now this is very ironic because we are repeating reviewing recursion, and the whole idea of recursion is calling a function inside of a function, basically repeating. But yeah, we're going to review recursion, what it does. We're going to give you a new, I guess, analogy to look at to understand recursion a bit more.
Wait, would you be calling it recursion?
I don't understand what you're saying.
Because isn't like non-code recursion, doesn't it mean like repeating something?
Yeah. So if you've seen this,
so it's technically recursion.
Sure.
Repeating recursion.
Yeah, you're right. Yeah. Yeah. So just gonna go on a tangent. Some of you will see recursion in math as well, so don't get freaked out. It's a similar topic, but back on the agenda. We're gonna review recursion, show you guys a new example or an analogy, and finally answer a question and code it and have fun. Yay.
Exactly. And now to get started off, first of all, let's remember what you guys remember. So over the past 2 weeks, we've introduced the idea of recursion. Last week, we did another problem, compared it to, the problem was about doing the exponent of a number. So like 5 raised to the second power, how we could do it using a while loop versus how we could do it using recursion. So who can remind us, like,
I have 5 words of this: base case and then function inside function.
Great. 100%, Avanish. Calculator right there. Base case is something which is super important. It's one of the main things which makes a recursive function. And then a function calling itself, that's the idea of recursion. Anybody else have any thoughts? Do you remember? Base case. You like big chase more. Alrighty, well, Avnish, definitely that's the right idea. And like Avnish said, yep.
Go ahead.
Like Avnish, you said, it's that idea you said of calling a function within a function, and the reason where we're doing that is because we're breaking a larger problem into smaller chunks.
Nice how you like visually did it with the font size and the words.
Yes, you picked up on that. Yep. It's breaking the larger idea like we had last week of raising a number to an exponent and making it into smaller pieces, which are much more easier to analyze. And in coding terms, like you said, a function calling itself, and it's an idea of making our programming skills more advanced. And
just saying, Marianne, your grammar is bothering me. You said much more better.
What?
Wow, that's not a good way to go. And actually,
I don't know why, but it just bothers me whenever anything is like just I hear something that isn't like perfectly correct. My brain just goes like, what is going on right now?
You just contradicted yourself. You just said you're not supposed to use the word like unless you're using an example.
Well, take a look.
You just said that while you were speaking.
Look at Google. If you guys go on Google and search up recursion, look what happens. If I hit enter, something cool I found out. Look what happens. It never finishes the loop. It's always gonna say, "Did you mean recursion? Did you mean recursion?" That's pretty cool. So
yeah, is that a Google Easter egg? Is that a Google Easter egg?
Wait, search up askew.
Search up what?
Askew.
Askew?
Yes.
Oh, look at that. It's tilted. It's rotated. If you guys can notice that.
No, that's so cool.
So if you ever forget
what? Wait, can you tell all the Google Easter eggs before so I know how to try them? All the Google Easter eggs.
Just search up Google Easter eggs, and then it's just
no, because one time if you search Thanos and then you go to the Thanos picture and then you click the gauntlet, the words will disappear. Like that went away like a few months ago or something.
Oh yeah, I used to do a barrel roll.
Okay.
It used to do, like work.
Wait. Go to the first link on there.
Oh.
Yeah.
Also do like the Easter egg where you go to like you go to Google and then you search like whenever you move your mouse, like the whole page breaks, the new tab breaks, like the letters.
And then search up ZergRush. ZergRush I think still works.
I think it's Zerg. Okay.
Yeah, and then you have to just shoot them.
What game is this?
ZergRush.
Well, there's
wait, can you do like the Easter eggs like within Google, not just clicking like websites?
This went from coding
there's a
program
so we're
to
gonna go back
Google Easter egg hunt.
And talk
for me, it like works when I just say do a barrel roll. It works for me.
I see.
Like the whole page tilts. But you know what's so cool? Search Mario Bros. Super Mario, and then there'll be a coin, and you can just click it.
And if you search up, wait, what's that game where there's
like, click the question mark. Click the question.
There we go.
Wait, what's that game where there's like the ball that bounces and hits like the blocks and comes back, and you have to use
that's
like
Breaker?
Atari.
Yeah, if you search
Atari Breakout.
Atari Breakout. If you search up Atari Breakout and go to the images, you can play Atari Breakout in the browser.
Well,
it doesn't work anymore. It doesn't work anymore.
Okay, guys, let's get back to track.
Yeah, there's a bunch of Google Easter eggs. I'm sure that they have probably hundreds. But if you forget recursion, you know now what to do from Tech Bytes. Search up recursion, and you should remember what it is.
Yep. Okay, so this is the example that we were talking about. So when trying to understand or explain it to someone else, trying to explain recursion and what recursive functions do, think of Russian dolls. How many of us know what Russian dolls are or have played with one before?
I know what they are, only because of a few shows.
It's like a it's not called a Russian doll. It's like some Russian word for the doll. It's like I forgot.
Okay, but you guys know what I'm talking about. It's basically a doll inside a doll inside a doll.
Forgot. It's called Matryoshka doll.
Thanks, Cardi.
Oh, okay, cool.
There's a Christmas movie that had it, so.
It's like when you open the doll, there's like a mini version of it inside.
Yeah. So that's exactly what recursive functions look like. You have a function and you're calling it inside itself. And then when you do call that function, you're calling it again until you get that last base case, and that's the last doll in the set of Russian dolls. And then you go back and then return values the same way as you would put the dolls back into each other. I don't
But
have
I
any
have
Russian
an
dolls at
example
home.
for like when it's confusing. So you just said it like it's in itself. So take two mirrors, like two mirrors side by side, and then put them like facing toward each other, and then you'll see like something that confuses your whole head. Like you can see inside like the mirror, it's like a reflection of his reflection of reflection. So that makes it like harder and confusing, and that represents like how hard it is. Like it's not that hard to write it in code, but it like if there's a mistake, it's like it's a general example.
Yep. That idea of going back and forth, super important, and it applies with a bunch of things you'll probably notice.
Yep. Yeah, so that was the example for Russian dolls, and let's take a look at today's problem. Or before that, let's just review parts of recursion. Again, someone else other than Avanish, I think. Yeah, Avanish, tell me what the two main parts are.
Base case and function.
I said someone other than Avanish.
Oh, sorry.
Say base chase.
Sorry.
Base chase.
It just comes.
Yeah, I know, it just comes. All right, so yeah, the parts of the recursion function is that base case, the if statement that ends a never-ending loop of calling a function inside itself. So basically that smallest Russian doll, which is basically the end. And then finally the else condition that tells the IDE that we need to call this function again and again. And that's basically opening the doll. I literally stayed at Sunday up to 10. Okay, coding my game after dinner. Okay. Cool, Avanish. That is very dedicated coding going on there. Really proud of you.
That's
saluting the flag. Salute.
Well,
no, I'm saluting a fellow coder.
Saluting back.
Okay, thank you.
Well, looks like we all do have a pretty good idea of what a recursive function entails.
Oh, this reminds me like the back days, like what the picture you showed. When I was in Math Olympiad, like one of the problems literally had like this picture, like the pyramid, number pyramid.
Well, now you can tell your Olympiad coach that you solved it with recursion, because today we're going to be taking the sum of a triangle from a given array, and essentially what we're going to be doing is using recursion in order to have a triangle with a bunch of numbers at the bottom and keep on taking the sum as we move on upwards. Now, the best way for me to show what this problem is actually about is probably do a quick little example right here. So say we have a triangle, right? We have numbers, we need 5 numbers. We'll do 1, 2, 3, 4, and then 5, all right? Now, the way this, our problem is, what it's asking us to do today is to take the sum and make a triangle so that we get that equilateral type of shape, right? Now, the way this works is that we're going to take the sum of all the numbers which are next to one another. So 1 plus 2 is 3. Then 2 plus 3, that's going to be 5. 4 plus 3, that's going to be 7. 5 plus 4, 9. Okay, now we go up. So 5 plus 3, 8. 7 and 5, that gives us 12. 7 and 9, that gets us 16. We continue this. 12 and 8, 20. 12 and 16, gets us 28. And then finally, we get the top of the triangle, 48. So it's that idea of taking the sum, and we're going to be doing this recursively in order to make that nice type of shape, which hopefully we can print out in our output box as well. So the idea is pretty simple, and this problem is probably one which could also be done with the while loop or something of the sort. But today we're going to be taking a look at how to do it recursively. So before we get to actually coding it, let's take a look at what we will require to do this.
Variables, which comes basically every session, but it's a good thing to know and remember that we basically can't code without variables because you need to contain those values in a container to be able to use it later on. So variables are numbers, strings, and then type of variable would be arrays that you store lists in. And yeah.
I have a meme, but I forgot to tell. So you think you can like imagine like this person. So you think, oh yeah, I'm so good at coding. I can code everything. Like, yeah, definition, function, recursion. And then when they ask you to write it, you're like stumbling on the keys.
On the names of the variables and functions, right?
Yeah, like they don't, like they just talk about it. They don't know how to like actually do it.
Yeah.
Self-promotion.
Well, secondly, guys, we're going to need some functions. Recursion, of course, utilizes that idea of calling the function from within itself, right? So we're going to, of course, use the base case and an else condition.
What was that?
I have a feeling that someone's sibling decided to prank them while they're in this class.
What?
Well, okay, but lastly is conditionals. Remember the base case is technically conditional because you are checking whether the case or the number of calls is the last one you want to do. So that is where we will use the if and else statement. And if it's not a base case, else we will continue to call the function inside itself.
Exactly. So now we actually get towards coding our own idea of a triangle. All right. As always, guys, the link will be available in the chat. All right, here it is. Oh, you can draw in REPLs now, looks like. Oh. Wow.
That's cool.
A dot draw file. Interesting, all right.
That's really cool. Also something, toucans have transparent skin.
What is it?
Toucans have transparent skin, like completely transparent skin.
Really?
Yeah, their actual like skin is really like completely transparent.
I did not know that.
Why are you guys searching up toucans?
We need to see that transparent skin.
You guys have a fave for transparent skin? That sounds weird.
Well, let's get on started creating, guys, a program for our special triangle, we can call it. The idea of having a triangle, putting some numbers in. Initially, we're going to pass in an array, and then we'll do some recursion type stuff with it. So first things first, got to make our function. We can call it create special
triangle.
Yes. And then as always, guys, with the recursive function, we're usually going to be passing in a variable. Can anybody remind me what that is? Starts with a P.
Parameter.
Yes, Avanish, head on, right? We'll call that we'll call it our array, or we'll call it we'll call it X. We'll say our array being passed in is our variable X, all right? Now, first things first, the idea is that we're going to be calling this function right here. We're going to say create a special triangle. Eventually, once we add some code, it'll pop up right there. And we're going to pass in an array. We could do the numbers 1, 2, 3, 4, and 5. Now, when we're thinking about our function, right, we got to have a base case and then all the stuff which happens when our base case is not met. And the base case is what we're going to get started off with. And that base case is going to be whenever the length of our array has reached 1 or less than 1, that's when we know we can stop with whatever we're doing with our function. So it's a good idea to start off and have that idea of what the base is going to be, and literally in our base case, right? So what we're going to do is say if the length of our array being passed in is less than 1, then we can return and go back to the previous call of whatever our function was. Now, we're not going to be returning anything today because what you guys will see is the whole thing with creating a special triangle is the idea of printing stuff correctly. And essentially, when we're printing out stuff, we don't need to really return anything, and you'll see where that will come in hand. But getting started off with our base case, when the length of our string, of our array is less than 1, then we'll just return and go back to the previous call. Now, what we have to do.
What is len? Len?
I remember, Avanish, it's like a small way to, it's a shortcut method to say the length of our string in Python. So say, if I comment this out, if I just print out the length of x, so this should print out how many elements are there in this array. So there's 5, right?
Yeah.
So I run, we get 5.
Oh, okay.
Good. Good question, though. Now, what we have to do is think about some other arrays we have. So we're initially starting off with this array of length of 5, right? Oh, okay, all right. I thought Avanish could not get out of the rep list. So great. If you guys are not on
You know what's kind of confusing? Because like, it's not like in the code, like you're screen sharing on Zoom. So when I see everything like you're coding, it's always late when I go to the actual replit on my website. And then it takes like 2 seconds to reload what you have done, like 2 seconds early on the Zoom when you're screen sharing.
There's probably some delay, I'd assume, of a couple seconds. But since you guys are on the Zoom, you guys are getting special premium access to seeing the code right away. So
discount. This sounds like you can make money.
Well,
2 second discount.
Yep, that is, yay, you guys are liking it, right? So sells us something. Now, guys, what we have to do is when our condition is not met, we have to think about what else is going to be happening. And when we think about that stuff, we have to think about what's going to happen. And what we're going to do is create a separate array. This could be like a temporary array. And this array will be responsible for holding the previous elements. So holding all of the other numbers which aren't being currently used in the sum. And you'll see what I mean in just a sec. So
wait, do you have hacker plan?
No.
No.
Oh.
All right. So what we're going to do is create a separate temporary array. And then this will be initially the length of whatever our array is minus 1. And we have to multiply this. So there's a concept in Python in which if we have a array with a 0 inside of it, that's just saying that we have a basic array initialized with a 0. And if we multiply that by the length of our array minus 1, that's what we did. The length of our array minus 1. This will, all right, there we go. Yeah, so this should create, if we can print this out actually to show you guys what this actually does. So there we go. Right now we have just an array filled with zeros, but less than 1. So we have 5 elements in our initial array. Now, when we're calling this function, this line of code, it creates an array filled with zeros because that's what I told the computer to do with these brackets. But it's going to be 1 less, so it's going to be 4 elements long. Now, this will come in hand because we're going to be taking the sum, and eventually we have to change these zeros. And in order to do that, we're going to have to go over, aka iterate, over the array. So when I talk about iterate, what do we usually think of? What type of loop are we going to use? Anybody have an idea? Can anybody remind us what type of loops we have? We have 2 different loops which we usually use, right?
While.
Yep, and the other is called You remember what the other one is called, Chase?
Or.
Yep, Avanish, exactly. And today, we're going to be utilizing a for loop or a while loop. What do you guys think? If we know how many times we're going to run the function, what does that usually mean?
Or.
Exactly, yep. So what we're going to do is say for, we can say A in range of from 0 till the length of our array minus 1. Now you guys will see why we're going minus 1, the length of our array, and it's because we're going to be skipping over an index in order to avoid a out of range error. So let's see how that comes into play. So what I'm going to do is say we can just create a variable. I'll say temp2 is equal to, and now right here is where we're going to do the actual summation of the elements which are next to one another, and say x, whatever the current element we're currently on, so at the A position, plus whatever is available at the next position. So in this case, it would be 1 plus 2, and then 2 plus 3, and then 3 plus 4, and then 4 plus 5. And now lastly, what we have to do is correct whatever these zeros are. We have to change them to actual numbers. So from 0 to whatever the value our sum has. So in order to do that, what we're going to do is say our array, aka the temp array, at the A position is equal to now whatever the number, the sum is from the temp2 variable. And what we can do is print out the sum as well. So sum is equal to 2. So as we go along, we should be able to see the sums of 1 plus 2, which is 3, 2 plus 3, 5, all of those being printed out as well. Now we're nearing the end, but there's something important which we still aren't doing. That actually being, in recursive function, we got the base case, but what's the other main important part of our recursive function?
Did you call it?
Exactly.
Oh yeah, you already called it.
So I'm calling it initially, but we got to call it from within itself, right? Call the function.
Oh yeah.
Yep, so we got to remember to do that. And what we're going to do is call our recursive function every time with our temporary array. So that way we can make our way all the way to the top. Now we're nearly all the way done, but we got one last line of code essentially to print out, and that being our actual array, which we're passing in. And the way we're going to do that is just print out our array at the end. Now the reason why we're printing out our array is at the end is so that we can have a sort of a triangle format in Replit the best way we can. Obviously we can't have it nicely formatted, but we should be able to see us go from smaller arrays to the idea of a larger array and resemble that shape of a triangle that getting steeper and steeper until we only have one sum at the very top. So we already mapped out our initial idea of 1, 2, 3, 4, 5, right? We saw it go all the way to the top. Let's see how it goes in code now. There we go, 1, 2, 3, 4, 5. And then the sum of 1 plus 2, which is 3 right there. 2 and 3, 5, 4 and 3, 7, 5 and 4, 9. Making our way all the way to the top until we reach our sum of the triangle, which would be 48. As we can see, our recursive function, we are going through the bases with, there we go, 1 plus 2, which first happens, which is 3. 2 plus 3 then happens, which is 5. And working our way all the way to the top.
Can you leave a space after sum is equal to 48? Like just put print, nothing, because you want like, I like to have a neat, like when it prints out. Because like after your like between your sum is equal to 48 and the pyramid 48, like you can have spacing.
Mr. Perfectionist, Dominique, all right? Don't worry, I'll comment this line of code out. We'll just do the triangle. There we go. So if I hit run now, we just have the triangle showing up, all the sums in a recursive way. And remember, main thing is, guys, the reason which is important is that in this base case, as opposed to in the weeks past, we're not returning anything. And the reason that is because we just want to make sure that we can use recursion to make our print statements look nice and take the sums of the adjacent elements right here. And this could apply to as many numbers we want. We could keep on adding 6, 7, 8, 9, 10. Go as many as we want, and we would see.
Between 7 and 8.
Yeah.
Oh, yeah. And we should see our triangle still being made. There we go.
Wait, can you do it up to the max? I just want to do the max to everything.
That would be a bunch of numbers, but what we could do is.
Just say do it up to 50. or 1,000 or 100,000 or a million.
Well, okay, how about this? We can do a quick for loop and say for x in range of 50, and we'll just add 50 elements in our array. So we'll say, I'll call it base array, set that equal to just a empty array, and then we'll do our base array adding the variable x. And this should append us 50 numbers. And then at the end, we'll call our function with the array with 50 elements. Let's see how that goes. Probably gonna take some time to run. Oh, well, that's not even looking like a triangle anymore. But
that looks like a sea of numbers. It's like it's what a hacker sees every day.
Yep. And eventually we're gonna reach that final sum, looks like. So it still does work, and we could probably test the limits and even go to 100, and we'll see a bunch of more numbers.
You know what was so cool? So one time on my Chrome, you know, like you have bookmarks. So I right clicked and I had like 71 bookmarks on the Chromebook, like on my school Chromebook, and then I pressed open all 70, and then you know what happened? Like the whole thing just crashed.
Yeah, I don't think the CPU of a Chromebook can handle 70.
The Chromebook is so little, like it can't handle like that much.
Yeah. Well, that brings us till the end of the coding. Anybody have any questions about recursion in general, the code from today? Today is the final day, so make sure that we understand the idea. It's all engraved in our mind.
Did you just create, like, for the variable temp and temp2, are those random names, or are they represent something?
So temp2 represents the sum every time. So like say we have 1 and 2, 3, right? So 1 and 2, the sum of that is 3. And then temp is just representing our original array we're changing out.
Okay.
Alrighty then. Alrighty guys, well then that brings us till the end of our 15th week of algorithmic programming. Hopefully you guys had a fun time over the past 3 weeks with recursion, of us going back to back to back, get it, for recursion. But we'll definitely be looking to use recursion whenever we can, because it's an advanced topic and it's always good to show that you know how to do some advanced topics in coding.
Guess what? I have five weeks of school left. How about you guys?
Yeah.
I think we only have like 3.5, 4 weeks.
Yeah.
So you're in 10th or 9th?
12.
12.
You're in 12th?
Yeah.
What? You're gonna go to college next?
Yeah.
Okay, then remember saluting Avanish.
We will, definitely.
Never forget. We'll bookmark it, Avanish, don't worry.
You will bookmark it? That's not what I was expecting.
Well,
Avanish, you'll never believe what grade I'm in.
You're in some grade.
I did 18 years.
18 years.
18 years of what?
School.
Sure.
I am. After high school came college and then my master's degree, which is another 6 years on top of the 12.
We salute Joe.
Wait, I have a question. What did you get a master's degree in?
Library science. Every librarian here has a master's degree.
Well, a lot of education.
What doctorate?
You can get a doctorate in library science. I do not have one, nor would it be worth it.
Okay.
Well, guys, other than that, remember this Wednesday we do have product development, so we'll be starting a new project and drop any ideas in the Google Classroom. But enjoy the weather. We got some good weather for the upcoming couple of days. And then other than that, guys, take care. See you.
I forgot to